Hey guys, welcome back to my Practically Imperfect Life. Today's video is actually one that's been requested by a couple of viewers doing a comparison between a more traditional chemistry course and a non-traditional chemistry course. If you have been a viewer for a while, you know that both of my kids, one who's a sophomore and one who's a junior, have both taken the Berean Builders high school chemistry course. My daughter took it last year and my son is finishing it up this year. But this year they both also took Chemistry in the Kitchen from Guest Hollow, which is a non-traditional approach to teaching chemistry. Now, we taught it as more of a science elective in our homeschool, but I was really interested to see how the two different courses approached the subject of chemistry, how concepts were covered and taught, and really what were the different methods that were being used and how did that change the retention of the material. And I don't want this to be a video where I'm saying one is good and one is bad, because I really do like both curriculum, and there are a lot of great pros to each of them depending on what your students' long-term goals are and what type of a learner they are. If you would like more details, I have a couple of videos that I can recommend. I did some curriculum review videos in the past couple of weeks. Those can be found in my curriculum choices playlist. In one of them, I go through our science courses for this year, and another one I go through our electives. So I cover both the Berean Builders chemistry in pretty great detail in the science one, and then the chemistry in the kitchen in the electives video. I also have a playlist that's specifically about Guest Hollow curriculum, and there is a whole video that's introducing chemistry in the kitchen, talking more about that course, and then one on lesson planning. So if you'd like to get a lot more detail on them, check out those videos. But today I really wanted to focus in on topics that are covered in the different curriculum and really just how those things are approached and how they are organized. So I have actually several pages of notes. I'm not going to be reading it verbatim, but basically what I did is I went through the Berean Builders course and I jotted down all of the different key topics and things that are covered. And then I went through my Guest Hollow curriculum, the chemistry in the kitchen, and I went through and I kind of highlighted what things from Berean Builders are also covered in that, and then some things that are covered in chemistry in the kitchen that aren't covered in Berean Builders, and then just some notes on kind of how those things are done. I will say one of the biggest differences between these two courses is that the traditional chemistry courses will almost always include a lot of math. Traditional chemistry just has a lot of calculations, whether that's figuring out how to balance equations or determining how many moles of something that you need or what is the percent yield that we should get, even doing conversions between different types of units. There's just a lot of math, and I will kind of note on different chapters in the Berean Builders where there's quite a bit of math that's included in there. That is one big difference. Chemistry in the Kitchen is teaching you the theory behind these things and how they work, like the principle, but it's not teaching you any of the calculations. The other really big difference is in terms of how things are introduced and structured. Traditional chemistry, and I've seen this in different chemistry textbooks, follows a pretty predictable order of how they introduce things. And you'll see that kind of as I go through these in the order that they're introduced in Berean Builders. Whereas Chemistry in the Kitchen tends to kind of jump from topic to topic. They might introduce something in week 4 and then revisit it in week 16, but they're talked about in different ways and to different degrees. So you won't really have a week that we're only learning about polar molecules. That might be introduced one week in Chemistry in the Kitchen, but you're going to revisit it at several times during the course of the year as you're talking about different topics and doing different types of cooking experiments. So it's very different in that approach. But let me just start kind of going through some of the topics that are covered. So Berean Builder starts off with the very first chapter teaching you about measurements. They discuss what significant figures are. How do you do unit conversions? What is scientific notation? How would you write that down? What are ways that we measure area and volume, mass, and time? And then density. Now, Chemistry in the Kitchen will talk about density, not calculating density, but what does density actually mean? How would we look at it? What are some experiments we can do to visualize it? And it will talk a bit about weighing and measuring, but it uses it largely in terms of how we would use that again in the kitchen. So you are learning some of the skills, just not necessarily to the precise degree that you are in the Berean Builders. Significant figures are something that's used in a lot of scientific math. You'll see it again in physics courses. And it's simply a matter of how we end up kind of finalizing our answer when we're doing calculations in a lot of science courses. Like, because so much of chemistry is going to have math, they really wanted to put this at the beginning because you need to utilize that for all of the different calculations you're learning throughout the whole course of the year. So Berean Builders is very heavy on that, whereas Chemistry in the Kitchen is just doing kind of a basic approach to that. Chapter 2 of Berean Builders gets into what matter is. So talking about mixtures, substances, what's a homogeneous substance, what's mass conservation, what is an element, and what is a compound, Dalton's atomic theory, laws of multiple proportions. Those are the kind of things that are covered in the matter chapter. Now, Chemistry in the Kitchen has a 4-week supplement that they recommend or suggest that you do before you actually dive into the 36-week curriculum if your child has no chemistry experience at all. If like all of this is brand new information to them. And in that 4-week supplement, they really do focus in hard on some chemistry concepts. There's specific books for that 4-week supplement. There's 2 books that are recommended, lots of videos, lots of more things that feel more like, a little more like traditional chemistry experiments, really kind of teaching some basic principles. And one of the things that's introduced in that 4-week supplement is the elements and compounds. So what are they and what's the difference between an element and a compound? Having looked at that, we did not do that simply because my kids were already in a traditional chemistry course, but if I wasn't using the Berean Builders along with it, I would have definitely done that 4-week supplement. Highly recommend it for really introducing some of those principles. Then in chapter 3, Berean Builders gets into atoms and elements. So what is an element? How do we abbreviate it? What does it look like on the periodic table? What is the periodic table? They talk about radiation, nuclear weapons, light waves, electromagnetic spectrum, the Bohr model of atoms, energy of light. Now, a lot of these concepts are introduced in Chemistry in the Kitchen as well. The periodic table is taught initially in that 4-week supplement, as is what is an element and the Bohr model. In fact, there is an activity where you can create a model of like the Bohr model of an atom. Now, there isn't an activity specifically like that with Chemistry in the Kitchen, or with Berean Builders. However, I have a model kit that I got to go along with our chemistry courses, and we used that to actually create our own models of different types of atoms. And my kids found that that was really helpful to be able to create like a 3D visual display. So big kudos to Chemistry in the Kitchen for including that in the 4-week supplement, because that is something that can be hard for kids to understand. Now, while the periodic table is introduced in this chapter in Berean Builders and the different elements are listed, there's a couple of elements in particular that the Berean Builders course recommends your student memorize. Like, know the abbreviation for it, know its atomic number and things like that. Not all of them, but just a few kind of core ones. Now, in Chemistry in the Kitchen, while you're introduced to like the periodic table and everything, you're actually going to learn more about individual elements, but you're going to learn about them one at a time. Each day, there is a recommendation that you read certain pages in this elements book. It's on their book list, and it gives some information on that element. And then there is a link to a video. It's a series called the Periodic Table of Videos, I believe is the name of the series. It's put on by a college, and they do these short videos really introducing those different elements. It's a really interesting little video series. They'll give examples of things, sometimes do experiments. It's nothing too terribly long, and pretty entertaining to watch. So they got the introduction to all the elements, but instead of it being introduced all in one chapter, it's broken up day after day after day throughout almost the entire year. Then Berean Builders moves into basically atomic models. So electrons and their placements. So if I'm losing you here, just know I'm talking through topics. So where are electrons in our element? Where are they at? We're talking about valence electrons. How do electrons act, basically? Like, why is it that two oxygen atoms want to come together and form a bond? And it's all because of how their valence electrons want to interact with each other and how many are there. There's also an introduction to like Lewis structures. So how do we draw these out basically on a piece of paper? How would we show that model, which helps us to then again see why things interact together. Introducing metals, nonmetals, ionic compounds. And this again is all introduced initially in the 4-week supplement for Chemistry in the Kitchen. Now specifically there's 2 books that I mentioned that the supplement uses. One book called The Elements, Ingredients of the Universe, and this is available either as a book or as a PDF download. And then there's The Joy of Chemistry, a quick study guide. And then there's a lot of different videos and hands-on things. So a lot of these concepts from this 4th chapter in Berean Builders about the view of atoms and, you know, what are protons, what are neutrons, how do we know how many an atom has, how do we know about the electrons, all of that is introduced in that supplement. Again, you'll touch upon it at different times throughout the year in Chemistry in the Kitchen, but it's really kind of hit more hardcore in that 4-week supplement. Then in our traditional class course, our Berean Builders course, we're moving on to covalent compounds and molecular geometry. So molecular geometry says, well, what does this look like in 3D? What would this particular molecule, once all these bonds are formed, what shape would it have, and what does that mean for how it would react? Now in our Berean Builders course, we again used our model kit to be able to create some of these because it can be kind of hard to even look at these pictures that are supposed to be drawn to look 3D in a book and to really understand them, but building models is extremely helpful. So the traditional course covered everything from naming covalent compounds, the Lewis structure of covalent compounds, periodic table properties and how they will affect covalent compounds, covalent bonds, polar covalent bonds, molecules in 3D, a polar versus a non-polar molecule and why that is important. So Chemistry in the Kitchen does cover quite a bit on covalent bonds and on water molecules in particular, because the way water molecules react with things and how they work is so important in how everything works in the kitchen and within our bodies and things like that. So that is introduced in different ways. A couple of examples here I put from this particular week. In week 2 of Chemistry in the Kitchen, the kids made marshmallows, they made a whipped topping, they made eggs Benedict, and all of that was to highlight what they were learning about covalent bonds and water molecules and things like that. They are reading in different books. We were reading through Culinary Reactions was the first book, and then What Einstein Told Us Cook, where they're learning about fats and oils and gels, which gets into nonpolar molecules, right? Because that's part of the reason why, you know, oil won't mix with water, why they will separate, because one is polar and one is nonpolar. So they are learning about that concept. They're just learning about it in a different way. Then in our traditional course, we get into physical and chemical changes. So what is the difference between a physical and chemical change? Talk about phase changes, states of matter. That's something that we also cover in the kitchen, talking about, you know, something as simple as water goes from ice to a liquid to water vapor. That's a phase change. So we're obviously seeing that through different cooking processes. There's a bit more detail on all of this in the traditional chemistry course. So we're talking about temperature changes, the kinetic theory of matter, what exactly is a chemical reaction, and here's where another big difference comes in. Now we're getting into balancing chemical equations. So if we have these couple of things reacting together and creating that, how many of all of these do I have to produce a certain number of this? There is a lot of time spent in the Berean Builders textbook teaching this, because it's one of those things where it's like, okay, well, I've got 5 of this over here, but now I've got 4 of this over there. So I have to end up making this many of this, and then change this to that, and like going back and forth in order to create a balanced equation. They also specify different types of reactions more in the traditional course. So what are formation reactions, decomposition reactions, single and double displacement reactions. Combustion reactions are taught in both courses, but again, we're looking specifically at how we would balance those types of reactions in the Berean Builders course versus the Chemistry in the Kitchen. In Chemistry in the Kitchen, we're looking more at, well, what is combustion and kind of what's going on in there versus let's write out the actual reaction. So here's where we're going to start to see a little more of a split between the courses. The 7th chapter in Berean Builders is all about stoichiometry. Stoichiometry is just a fancy word for the math we use in chemistry. It's the way that we will go from a number of grams of something to a number of moles of something. How do we do those calculations? So as you can imagine, that chapter is very heavy on math concepts. There's a lot of time spent doing practice problems and just getting good at that, practicing your significant digits and making sure that we're writing out the answers correctly, that we're using proper units. In fact, there's a 2nd chapter that goes even further into stoichiometry, but here we're looking at specific types of things. Like if we are doing a reaction, what's our percent yield? What's the difference between an empirical formula and a molecular formula? And what do those different empirical formulas look like for things like metal oxides, combustion analysis? If we know the percent composition of something that we're given, can we go back and create an empirical formula for it? None of that is stuff that they'll do in the Chemistry in the Kitchen course, because this is all very math-based. And since we're not covering math and Chemistry in the Kitchen, basically chapters 7 and 8 of Berean Builders, just assume you're not going to see any of that stuff in the other course. Then we're moving on to solvents and solutions. And solutions are covered heavily in both, but again, with a little bit different focus. So Berean Builders is going to teach you what is a solution, what are solutes, what are solvents, how does temperature affect solubility, what are precipitates, how do we determine the concentration, what is molarity and molality, how do we figure out those. A lot of the general concepts about solutions are covered over many different weeks at different points in Chemistry in the Kitchen, and a lot of time that's worked into different types of like mini experiments that you do. And even thinking about things like, if I change the temperature of the water, how does that change how fast something dissolves in that water? So again, you're seeing more of that practical application of it, whereas we're learning that concept initially in Berean Builders, but then we're doing the math associated with it. If I'm giving you certain numbers about things, find this. Then we go to gases in Berean Builders. So in gases, we start to introduce more laws. So, in chemistry, we have lots of different laws we follow. There's Boyle's law, there's Charles' law, Dalton's law of partial pressures. So you'll have to memorize those laws and different calculations, different formulas that you need to know. You do need to be able to memorize those formulas to be able to do the math associated with it. Now, in Chemistry in the Kitchen, I think I noted there was a brief video. There was one video that introduced multiple different gas laws that's included on one of the weeks. So you'll actually learn, the formal name of that law and basically what that law is telling you. But we're not memorizing formulas. We're just getting the introduction to what is that telling us about these gases. Acids and bases is the next chapter in Berean Builders. So we're on chapter 11 out of 16 at this point. Acids and bases are something that are really easy to do experiments on in the kitchen. We did a cabbage juice pH indicator. We made what are called chameleon eggs, which they're not really chameleon eggs, but it's a reaction that you do, and it creates like these little bubble things that change color. So it was a really interesting little thing to do. We learned what the pH scale is, how to do a litmus test. I mean, really, you'll get a pretty good understanding with either course of what acids and bases are. It's just, again, we're adding in the math component. Berean Builders, we're talking about the chemical definition, chemical equations for acid-base reactions, acid-base neutralization, acid-base titrations. So again, we're learning all of that in Chemistry in the Kitchen as well. We're just learning it in a different way, and we're doing a whole bunch of different types of recipes that are demonstrating how acids and bases react together. Chapter 12 in Berean Builders goes over reduction and oxidation. So oxidation states, determining an oxidation state, what is reduction and oxidation, and then that transitions to understanding the basics of batteries and galvanic cells, counting electrons, doing redox reactions, redox equations, and then introducing some math into that as well. We are learning about reduction and oxidation in Chemistry in the Kitchen. It's introduced a couple of different times briefly, and then there's a couple of videos on how it is that batteries work, because that's the type of reaction that forms a simple battery. So that's where that part gets introduced. There's not really a recipe that goes along with that, but they do introduce some videos that explain that more. Chapter 13 of Berean Builders is all about heat. So what is heat? What's the difference between a capital C calorie, a lowercase c calorie, and a joule? What is specific heat capacity? How do we measure heat? What is latent heat? What is the heat that's associated with chemical reactions? And what's an endothermic and exothermic reaction? In Chemistry in the Kitchen, we are also learning about heat. We learn about the different types of calories. We are introduced to specific heat capacity, what that means, not how to calculate it, but what it means, and also how heat will affect chemical reactions. In a way, this sort of introduces some of the stuff that's covered in the next chapter of Berean Builders, which is all about thermodynamics. Thermodynamics is enthalpy, enthalpy change in bond energies, Hess's law, activation energy, changes in entropy, Gibbs free energy, and how all of that interacts. This was another chapter that was very, very, very heavy on the calculations in the Berean Builders course. You have to understand what all of these different things are, and you have to understand the various formulas you're going to use, but then it's a lot of calculations. I didn't feel like there was a ton about thermodynamics, specifically like these topics in Chemistry in the Kitchen, but this is so specific to these, particular types of equations. Like I mentioned, we're learning a lot about how heat is changing reactions, changing the pace of reactions, rate equations, collision theory, how do we change the rate of a reaction, what is activation energy, temperature and the rate constant, and catalysts. Out of all of that, most specifically, we do cover catalysts in Chemistry in the Kitchen, because there are things you can add to different recipes that will basically speed up a reaction and make something happen quicker. And so we do utilize those in a couple of different ways. We're covering a lot of the similar theories. I mean, you're going to understand that if you change the pressure, if you change the heat, or if you cool something down, you're going to change how quickly that recipe comes together or how something cooks or bakes. It's all about principles rather than getting really specific with that terminology. And then the last chapter of Berean Builders is on chemical equilibrium. So how do we establish chemical equilibrium? What is an equilibrium constant? What's the chemical meaning of that? That is not really something that's covered in Chemistry in the Kitchen, because it is very specific on doing different types of calculations. So I know I talked through a whole bunch of stuff super, super fast, and you're probably like, oh my gosh, like it felt like you were bouncing back and forth a whole bunch. The point of all of that is that a lot of the different topics are covered in both courses. It's just a matter that they are covered in a very specific order over a very specific time frame. We're talking about heat in one chapter of Berean Builders, and we're learning a lot about it. We're learning a lot of calculations and formulas, and we're practicing that a whole bunch. Whereas we're going to be introduced to how heat affects reactions at multiple different points over the year, whether that be from books or videos or a particular recipe in Chemistry in the Kitchen. When it comes to learning about elements, while we're going to be using those elements throughout the year in the traditional course to do our different reactions in our labs and things like that, we are focusing heavily on learning about the structure of them and their properties and stuff early on in the year. Whereas in Chemistry in the Kitchen, we're gonna go into different elements one by one over the whole year. I made a couple of other big notes on things that I noticed that were different. When you look at the Chemistry in the Kitchen course, a lot of times the books that are on the reading list are not going to stand out as being, oh my gosh, that looks like traditional chemistry, because they're not. They're meant to be introducing culinary concepts that teach you chemistry principles. So Culinary Reactions is the very first kind of spine book, and you have chapters on different elements of cooking or baking, and it explains the chemistry that's going on, but it's doing it all in terms of food and food processes. By comparison, a lot of the recommended videos on each week of the schedule for Chemistry in the Kitchen will seem more like chemistry to you. There will be very specific videos on a chemistry concept. For example, there was a video from SciShow called Why Do Atoms Bond? Another one, Covalent versus Ionic Bonds, the genius of the periodic table. So these are very specific videos that are just talking about some element of chemistry. They're not using a recipe or anything like that. They're simply talking about and teaching that chemistry concept. Another thing I noticed is that the Chemistry in the Kitchen course almost feels more like an introduction to a lot of different areas of chemistry all in one. I was a chemistry major, so I had to take a general chemistry course, then I took an organic chemistry course, and I took an inorganic chemistry course, and I took a biochemistry course. And each one of those courses focuses in on different things. Like organic chemistry is a lot of the chemistry of life, a lot of carbon reactions and things that are happening, whereas biochemistry is where we got into things like proteins and amino acids and how do they shape themselves and how do they interact and how does that affect things within life forms usually. And a lot of that is introduced at different times throughout Chemistry in the Kitchen. Proteins and amino acids and fats and starches and sugars, those are talked about a lot, and I mean on many different weeks. You think about it, every time you cook, you're doing something that's changing proteins, right? When you are whipping something up, you're breaking proteins apart and then they're reforming in different ways. When you heat something up, you're denaturing proteins, and that's going to change the texture and the color and the way things taste. So we are getting an introduction to some biochemistry concepts. And then the last couple of weeks, we're using a book called Carbon Chemistry, which is very much an organic chemistry type book. So you're getting a little bit of an introduction to a lot of different areas of chemistry. You're not necessarily going to be an expert in all of those areas, but you're getting that introduction. Whereas in the traditional chemistry course, we're really just learning these kind of main things on chemistry. We're not touching organic chemistry. We're not touching biochemistry. You might see like a little sentence here or there, but we're really not worried about any of that stuff. So either this video gave you somewhat of a comparison between the two courses or it confused you completely. I apologize if it made more confusion than it was helpful. I had literally typed up all of the different topics over the course of 3 pages that are covered in the Berean Builders course, and then I went through and I was highlighting in red the things that were also covered in Chemistry in the Kitchen and then adding in notes, plus then I had more notes at the back. It's hard to do an exact side-by-side comparison of courses that are so wildly different. But I understand that as a parent, you want to make sure that whichever approach you're taking to a subject, you want to make sure that those key ideas or key concepts that your student needs to know are being covered. Because your student might go on to college and need to take a chemistry course, and it's going to be taught in a traditional format. I don't know of any colleges that teach chemistry through cooking. You're going to have to do the math. You're going to have to memorize the laws and the formulas. You're going to have to balance equations. That's just how chemistry is taught in college. And it might just be that you want your student to have a basic understanding of general chemistry principles, so that way they can, if they read about something or hear about something later, they have an understanding of that. And maybe your child has no idea what they want to study and you just want to make sure they're prepared either way. I will say that both courses do cover all of the kind of basic things you need to know. I like how things are introduced multiple times in multiple ways and always with a practical application in chemistry in the kitchen. I think that's something that's really nice because there's not a whole lot of high school students that are like, yes, I want to be a chemist. They might have to take a chemistry course for a major they're doing, but they don't have to have all of those laws memorized, and they don't have to know the formula for specific heat capacity. They don't need to know that. But it is good to understand the basics of why certain things are happening in the atmosphere in terms of temperature and pressure and how things are reacting, how things are happening in your body, how things are happening in the kitchen. Like having a basic understanding about why all that stuff works and what's going on, I think is good to have. And the way that it is taught in chemistry in the kitchen through books and through videos and through the hands-on activities, there's kind of seeing how all of these different ideas kind of come together rather than here's a chapter and here's specifically what we're learning and then we're going to completely switch gears to the next chapter. It's like, oh, hey, remember we learned about this a little bit several weeks ago, and now let's look and see how it ties into this, and then let's bake something that's going to show that. And if you do those experiments, which are like those recipes, and your student's done the reading or watched the videos, and then you talk about it afterwards, they will probably come to grasp that concept a little bit better than if they memorize it once for a test and then don't see it again for the rest of the year. So if that is a way of learning that is helpful for your student, then you might find something like chemistry in the kitchen to be a better fit. If your student likes to learn things in a very specific format, let's just compare it to a math course. If your student likes spiral type learning, like a Saxon math type learning, they'll like how they're learning for chemistry in the kitchen. If your student is more of a mastery and then move on type student, where they wanted to learn about division, and once they had division down, they wanted to move on, and they wanted to learn about fractions, and once they knew fractions, they wanted to move on, they'd probably like a traditional chemistry course a little better because they are kind of separating out those different things as you go through the course. So it's just a different approach to teaching the same subject. And so that's a little bit of a comparison between a traditional chemistry course and a non-traditional chemistry course. Obviously, there are a lot of different curriculum companies out there that sell both types of courses. These are just two that we have experience with using in our homeschool, and so I felt comfortable doing a little bit of a side-by-side comparison between the two. If you have any specific questions about either one of the curriculum that I've talked about, or if I just completely confused you on something in this video, which I very well may have, I probably could have organized this better, please feel free to drop a comment and I will try to explain things a little further or in a little bit of a better way. But as always, I appreciate you guys being here. As I've said at the start of the video, if you'd like to find out more about these two programs in particular, I have the videos down below. You can check out my curriculum review videos and find information on both there. And in my guest hello playlist, you can find quite a bit about the chemistry in the kitchen course. Thanks so much for joining me today, guys. I'll see you in the next one. Happy homeschooling.